And that's what we're going to talk about, in addition to application-related, except for our maintenance and maintenance. This safety and reliability is related outside of these structures. Applications for all our connectors. It all encounters a very core problem, very central question. It's called the environment. Environment, how it determines structure. So for example, my connectors are underwater, okay? In the deep sea, used in snow-capped mountains. In the deep sea, used in aviation, in different environments. The structural requirements are different. In a military setting, plug and unplug maintenance of my connector. I'd better not need any external intervention. Because under conditions of war, there's no way I'm carrying a kit. What kind of thing to carry? I ran to repair my things. That's impossible. So it's disassembly and maintenance. It is best to do it manually. No external force is required. So it doesn't need screws. Preferably, no screws are required. No need for welding. Then you can't operate these things. So it's very simple. That is too crimp. Do you want a push-pull lock? This is a typical example of a military connector. That connector in the deep sea, in the water. We need tightness. It needs to be very sealed. Well, what about, for example, in some special cases, this harsh environment, dust pollution and so on in this environment, then our connector, it has to be able to withstand the dust, withstand static electricity, can withstand ultraviolet light, acid and alkali tolerance, this pollution of high acid and alkali. So its structure determines the environment. It's decided. The structure of my product itself, just different from others. Is this caused by the environment? The environment causes. What about us now? From our entire connector. What's your industry? And our entire application system can be taken into account. It has such a big impact on the connector. It's related to structure. There are so many. Then a lot of people will often think about it. Since the customer's application scenario, so strange, so complicated. So how do we go about doing it? Our design logic. Now that's hard to say. It's certainly challenging. But you said it was simple. It's not that hard. The logic of the entire structure. We always have one point. Throughout a point, connectors are designed for function. The whole connector doesn't matter what your structure looks like. You should first focus on your main function. Do I want to connect? I want to connect. I want connectivity and security. Do I want signal or power? When you settle this down, the rest of it, my mechanics are fine. My electrical structure is also good. My seal signal, mine is fine. In fact, it is all as an auxiliary way. Add it to it step by step. Add it step by step. Not that I had to do it in the first place. It's like I used Play-Doh to make a house. Okay? The first thing I knew I wanted to live in was for people. So it's a house. After I read the house, I'll find out that I need furniture. I'm going to need electrical appliances. What kind of things do I need? It is increased step by step according to your usage requirements. And so is our logic. After confirming the customer's application scenario, according to this specific application scenario, choose your materials. Order some of your contacts. Some basic parameters. Target? And then do some of this theoretical conformance. And this satisfaction, this design verification, and according to this design verification, let's adjust our process or our target. And that's what we're going to talk about today. A very crucial link. This app. With this structure of our connector, the connection between them, thank you very much.